So are there some tools you're using during development to make sure that Speedify is high quality?
Yes, we've got a whole host of tools like Facebook's Infer. We've got LLVM's address sanitizer, memory sanitizer, thread sanitizer, undefined behavior sanitizer. We've got the leak sanitizer. We've got Valgrind and all of its friends like Hellgrind and Memcheck, and even some performance tooling from Valgrind. We've got other tools on the server side that I'm not as familiar with, but it's got Vols, Nuclei, Trivi, NJScan, Dependabot, and GetLeaks.
Yeah, gotta make sure we don't accidentally check a password in, right?
Absolutely not. And it's all run in CI, not locally.
What's CI?
So CI is a wonderful tool for making sure that you don't forget to do the important bits of testing your code. We've got Jenkins and some GitHub Actions for running certain checks and test suites when code changes that needs to be retested, or just on a timer. For example, dependencies can be checked on a timer, but when code changes, gotta run those tests again.
Right. Okay, so it's doing all those standard tasks and running those tests over and over. So how many tests does the CI system actually run automatically?
35
35 tests?
suites.
So how many tests?
Give or take 1,000, approximately 1,061.
And how long does that take to run over 1,000 tests?
38 hours in total.
So every time someone changes one line of code in Speedify, you run 38 hours of tests on it? That's like 2 days.
Yes, but it doesn't take that long. We run them in parallel on these huge machines.
When I think about Speedify, though, it's not running on huge machines well, it is, but it's running on all sorts of things, though. It's running on iPhones and Android and laptops and Raspberry Pis. It doesn't all sound like just big servers in the cloud. How do you make sure it works on everything?
Right. So on these huge machines, we've got this virtual, we call it the town setup. We've got virtual clients and virtual servers and virtual networks that can emulate all of the weird situations that we see out in the real world.
The virtual networks part is really interesting. Can you talk about how you guys do that? Because different networks, we have customers on cellular, on Wi-Fi, and Ethernet, on fast connections, and slow connections,
right.
The edge of range.
Yeah, so we can emulate a local area network or a wide area network, and we can emulate what the internet looks like. We can access the internet from within this virtual town, and we can change the network parameters on all of these networks to see how Speedify behaves with a really weird LAN or a LAN with a bunch of parent-shared devices on it.
Are you enjoying this discussion so far? Drop your thoughts in a comment underneath the video. And while you're at it, subscribe to get notified about more videos like this. So, am I right? Speedify, the core of it is written in C++. Is that correct?
Yep.
So, how do you stop C++ code from crashing, right?
Well,
writing off the end of arrays and null pointer references and all that bad stuff that people associate with C++ code. Why doesn't Speedify crash?
Well, with tooling and testing. So there's a couple different kinds of tests. There's, on the far end, more exploratory sort of chaos engineering tests. And that's
chaos engineering.
Oh yeah, that's good fun stuff. Hey, send a bunch of malformed packets so these things bring up the down on a whim and just see what happens. There's more like example style tests where we have expected inputs and expected outputs, and the finest grained tests we have are for how the daemon responds to very particular inputs and very particular outputs. We don't have the full town running in those situations, but we have very precise control over the memory that the daemon is looking at and how it's handling it.
You were saying that you use something called sanitizers?
Yes. So running these unit tests under sanitizers is the best way that you have to know if there's anything strange that your code is doing at runtime.
So what is, for those of us who don't know, what is a sanitizer?
So sanitizer is running your regular code under a more instrumented library. So when you would otherwise just go to allocate memory or write into a buffer or do something on a couple different threads at the same time, normally there's no guarantees that that's going to be checked or perform the way that you expect it to. But when you run it under sanitizers, it is checked. You'll check that the memory you're reading from is initialized. You'll check that the threads that are talking to each other are synchronized. You'll check that when you allocate memory, you do it in a way that is always freed.
So why isn't Speedify just shipped with sanitizers?
They're expensive. In terms of the runtime, they slow everything down.
Slow you down, yeah.
So the best way to do it is to have these 38-hour test suites that run, some of which have sanitizers in them. And we throw the world at these things. I mean, every weird, malevolent agent of chaos sort of packet you can think of will hit the demon.
It sure will.
And it'll do it under a sanitizer.
So a big part of Speedify, though, isn't just that it doesn't crash and it's secure. It's that it's fast. Right there in the name. So how do you guys make sure that Speedify is fast?
Right. So we've got other more specialized kinds of tests for testing exactly that, performance. So these huge CSV tables containing specific network parameters and how many clients might be on the network, and then what the quality of those networks are and how they might degrade or change over time. And the stats running in the background, we test against the best possible circumstances for our users. So if we've got a couple network connections and they're all really good and one of them just drops out, we'll check that we're still using the other connections and getting as much as we possibly can out of them. And we run that along with all of our other tests.
So there are particular tools you're running to test the speed?
Right. So a lot of what we get comes from Speedify itself. Speedify has a CLI and it's got stats reporting right in there. So if you've got a WebSocket or access to the command line, you can read Speedify stats. But there are times where we want to be a little bit more specific. So we use things like TCP dump for taking PCAPs of how much traffic is going through and the timestamps associated with them and what those packets look like. There's also perf. And perf will give us a call-by-call measure of how much time we spent in different parts of our code base.
Now that you understand how we test Speedify, check out our other video about how Speedify really works, because we get into the nitty-gritty of how we combine connections to give you better speed, reliability, and security.